So now we're in chapter 5, which is going to be using trigonometry to do other things. So we're going to learn about polar coordinates and vectors. So if you haven't heard of polar coordinates before, we're going to start just by learning about them. So section 5.1 is polar coordinates. So first we're going to learn how to plot points using polar coordinates. And then we're going to convert from polar coordinates to rectangular coordinates. And then we'll learn to convert back the other way, convert from rectangular coordinates to polar coordinates, so back and forth basically. And then we're going to look a little bit at how to transform an equation. So transform equations from polar to rectangular form. We'll talk a little bit later about why that might be important to be able to do. So the origin in rectangular coordinates, so if you draw this XY system that we call the rectangular coordinates, and you talk about this point at the center, it's called the origin when you're talking about rectangular coordinates. But when you're talking about polar coordinates, you call that same point the pole, and it works differently. So that's going to be the pole. The positive x-axis in rectangular coordinates is called the polar axis in polar coordinates. So this is the polar axis, only the positive side. So that's our illustration. So we're going to plot points using polar coordinates. And if you have a point P in polar coordinates, it's represented by an ordered pair r, comma, theta. So the order is important. It's r theta, and then it's going to be essential that you put a degree symbol if the theta is in degrees, and that you don't put one if the theta is in radians. So if r is greater than 0, then r is the distance from the pole in the direction of theta. An angle measured from the polar axis counterclockwise. So if we put a point here, then r is this distance from the pole, and theta is the angle measured from the polar axis counterclockwise. So theta is an angle measured in degrees or radian, so the degree symbol again is super important, formed by the polar axis and a ray. So it's the ray from the pole to point P. So this is your point P. This is the ray going through point P. And theta is the angle from the polar axis to that ray. So r and theta are the polar coordinates of the point P. So you can see that if we were in rectangular coordinates, we would say go this far in the x direction and then go this far in the y direction, and that's how we name the point. We say it's the point A, comma, B, where A is the x direction, and B is the y direction. So this is a really different way of telling somebody how to get to a spot. We say, walk this far away from the pole at this angle, and then you'll get to the same point. So trigonometry is going to come into play here. So if you're asked to plot a point in polar coordinates, you're going to sweep out the angle theta counterclockwise if theta is positive, and clockwise if theta is negative, same as our convention has been. Then, this is a little tricky. If r is positive, start at the origin and travel along the ray formed by the angle theta, a distance r. But if r is negative, then you travel in a direction opposite the ray formed by the angle theta, a distance of the absolute value of r away from the pole. So let's look at some examples. We plot the point with polar coordinates 3, pi over 6. So the rings around the pole are each considered a distance of 1 away from the one before it. So if you are labeling, you could call the inner circle 1 and the next circle 2, or you could call each circle 1/2 and say this circle is 1, so then this is 1/2 and this is 2, this is 2.5 and this is 3, 3.5, 4, 4.5, 5. So that part's up to you. It's like the scale on a rectangular graph of you decide how much a box is worth. So I'm going to work on this little grid, but when we do it bigger in class, I think it will be easier to see. So I go up to the angle pi over 6, and then I go 3 concentric circles away from the origin, but I'm calling each circle a half. So I'm going to go 1/2, 1, 1.5, 2, 2.5, 3. Here's my point, 3, pi over 6. And I always find this a little confusing because I do the angle first and then the distance away from the center. But then the order is r theta. Okay, so that's the point 3, pi over 6. So now let's look at this point -3, pi over 6. So it still says we go up to the angle pi over 6, but then the negative r says we're going backwards along the ray. So it's like going reflecting through the pole. So we're going to go 1/2, 1, 1.5, 2, 2.5, 3. So here is the point with an angle pi over 6, but the r is -3, so we reflected through the pole. So do you see that another name for the first point could be 7 pi over 6? So we could go to 7 pi over 6 and then go -3 and get to the same place. And that the second point could be 7 pi over 6 +3, and you'll end up at the same point. So names of points in polar coordinates are not unique. Whereas if you tell somebody to go to this point on the XY coordinate system, there is only one way to tell them how to get there. You would say go -4 in the X direction, +4 in the Y direction. That's the one and only name for that point in rectangular coordinates. But hopefully you're seeing that in polar coordinates, it could have a lot of names for the very same point. So now we're just going to practice plotting a point in polar coordinates and figure out how to give it the other names that work. So this point, we're missing the problem actually here. So let's do the point 5, comma, pi over 3. Okay, so this is the convention of how we write the point in the simplest form, where the r is positive and the theta is between 0 and 2 pi. That's going to be the simplest way to write a point in polar coordinates. But so that we're sure about that, how do we write it other ways, let's go ahead and plot the point 5, comma, pi over 3. So here is the pi over 3 ray, and we're going to go 1, 2, 3, 4, 5. So here's our point, 5 pi over 3. So we plot the point, and now we're finding other polar coordinates of this same point. First, where the r is still positive, so it's still going to be 5, comma. But now we want to say, what's the name of this angle in negative if we get to it going this way? So if we count by pi over 3s, we have 1/3, 2/3, 3/3, 4/3, 5/3 in the negative direction. So negative 5 pi over 3 is how you write it with r positive and theta negative. Okay, so the B says, well, now have the theta be positive, but the r be negative. So if the r is negative, I'm going to be working over here from the angle 4 pi over 3 as my positive angle. Then I'm going to go backwards through the pole, negative 5. So this is the same point with a different name, 4 pi over 3 positive angle, negative 5r, ends up in the same place. So then the last one, C, says, oh yeah, if I go all the way around and then to pi over 3, I'm at the same spot. So that would be 2 pi, which is 6/3 plus 1/3. So 7 pi over 3, 5, is another name for that same point. So you can see that those homework problems are going to be pretty straightforward, just getting used to working with the new way of plotting points. So the next part is going to be converting from polar to rectangular coordinates. And this is the easy direction that all you do is look at the formulas and plug things in and you're good to go. So I'm going to make another movie for the second part so that I don't run out of time.